Hey guys, it's Vince. Today in this video, we're going to be discussing another client's retrofit that we're working on. And I wanted to do more videos like this because number one, I know you guys find it really interesting if you're doing a retrofit yourself. I'm getting a lot of questions on retrofits. And again, there is a lot of redundancy here, especially when we're looking at systems from overseas. And you'll see that now with this system. I've done previous videos where we've actually discussed a client that purchased a system that lives in Canada, and it's very similar, and you'll see that now with these chassis. So I'm going to just open up his pictures, and you can see here 4x8 chassis, nothing here that is special in terms of what we've seen in the past. Again, we do have the axis labeling, and we do have the externally mounted controller, which is mounted to the chassis. And China is doing this, I feel, my personal opinion, on most of these systems now because it's much easier to ship. It looks prettier to the client who's unaware of what exactly hindrance this has potentially with the system, and we'll speak of that as we go through here. But overall, again, it has a very clean appearance, looks very robust. The transmission aspect usually is rack and pinion on the two main axes, which is your X and Y, and then ball screw on your Z. Once again, just a lower cost implementation for automation. And we're going to cover our controller aspect. We'll come over here. You can see we've got our inverter switch, and they actually took the time to label this actual system. And they have their e-stop, power supply switch. This is interesting. I've never seen this before, an actual power break, but that's what they've got. 220-volt power supply, again, as far as the IEC port, and then digital interface to bring the VFD, which is, of course, mounted inside the controller. Definitive no-no for EMI mitigation. And, again, they mounted this externally to allow the end user direct access control to the VFD. Now, as we go inside, we see what China typically does. Actually, when I spoke to this client, he explained to me, I came highly recommended, and I really do appreciate that from Marcus. And we were going over some details, and he said he just did not want to take a chance knowing what the electronics are built like, and seeing some videos in the past that I've presented. He did his research. He called Gecko Drive, spoke to Marcus, and that's when he was directed to me, and we started breaking it down. And it was interesting because I didn't even see these pictures until recently, and this is exactly what we have. We have two 48-volt switching power supplies here. I believe this is a 5-volt power supply here. We can, of course, see that we're using tandem terminal outputs here, which is a definitive no-no. We've got tandem terminal outputs here, which is a definitive no-no. We are running 11 amp units, which means that this system is actually running 22 amps at 48 volts, which is really, really direct overkill, and a lot of EMI being produced by two of these units. Why I say that is, as you guys become more familiar with building your own system, this is an IDS system, and I'm going to cover that in a second. But what I want to discuss first is this power supply issue. There's this misconception that I'm seeing done consistently, because I'm getting lots of questions on it, that guys building their system assume that a stepper motor is like a typical DC or AC motor, in that it requires a large amount of amps and a buffer and all this neat stuff. Let's go over the basics. 98% of you are going to be wiring your motors in series, what's known as series as far as a stepper motor. A bipolar stepper motor typically has 4 leads. That's what we generally see on the market. There are different revisions of motors, some with 6, some with 8, but typically we see the bipolar series type configuration, which again is a 4-lead stepper motor. In which case, the actual power supply requirement as far as amperage for each drive is only 1/3 of the drive's actual amp rating. So when you think about that, that kind of transforms dramatically how you build your system. First of all, using 2 power supplies like this I've discussed in the past, you're just really bombarding the system with excess energy in terms of EMI. And then on top of that, you're never going to use this amount of amperage, ever even close. So there's nothing in here that requires that. The VFD is certainly not running off this. This is just powering the drives themselves. They could have mitigated the secondary power supply completely. What that tells me, once again, is that they lack knowledge of what they're talking about. And how I can prove that, we'll go on Gecko Drive's site. I'll insert the actual image for you to see what they directly explain as 1/3 of the actual amp rating drive itself. It's going to change everything on how you build your system. And when I say that, people don't realize how expensive their system is if they really don't understand what they're building. So again, we want to go through, we want to make sure that we're implementing the proper build process and selecting our components appropriately. Number one, to keep the price down. And number two, only select components that are going to really make a difference. Okay, we see the VFD here. And again, they're just doing a patch cord to run the digital VFD interface externally. I believe this, Steve, got two relays over here. Not sure what this is. I'm assuming it's just to control the VFD. But overall, we see the typical jacks in the back. No shielding being done, no grounding being done. And let's get back to my point on an IDS system, because I brought this up in previous videos, but I love doing, picturesque type examples of what an IDS system is. I'm just abbreviating an individual drive system. And what does that mean? Well, we've got 1 drive, 2 drive, 3 drive, 4 drive. Okay, this is a 4x8 chassis. Now you can do your homework. And there are some guys that want to build a controller like this that actually has 4 drives. Then they have to take each drive, multiply all of the terminals that each drive has, and then wire each individual motor connection on top of wiring every connection going to the breakout board, on top of wiring all of the drives to the power supplies, which of course in this format were not done correctly. And you're going to go through and figure out real quick, there is a lot of labor here, a lot. It's costly, it's time consuming, and on top of everything else, the smartest way I feel to do a system like this is see if there's a provision that you can actually use an integrated driver, which is going to save you a ton of time. But rather than talk about it, because I've done that in previous videos, let's look at it. Okay, this is once again individual drive. This is wired typically incorrectly by China, which means even in the amount of time it took them to wire this with unshielded cables, no grounding, no nothing, we're going to assume that this still was done within 5 to 10 hours of just labor, pure labor. Okay, and it's not even done correctly. Okay, and I'm saying that they're doing this every day. They're just trying to pump systems out. I think I'm being reasonable at assuming that. Okay, let's look at a system that's integrated. Now, a G540, which can run a 4x8 chassis comfortably, is once again an integrated drive. What does that mean? This little black box here in my controller, all this is housing is 4 drives. Inside that housing, you can see 1 drive here, 2, 3, 4. The motherboard or breakout board is also internally mounted inside the drive. You have 1 power supply, 1 e-stop, 1 power switch, 1 cooling fan for the drive, and again the IEC power port to accept power into the enclosure, power all of our electronics along with our fuse. Okay, the enclosure is right here. Super simple, nothing fancy, does the job of all of what we see right here. Minus, of course, the internally mounted VFD, which is done incorrectly anyways, because along with the double power supply running redundantly, just dispersing mass amounts of EMI, you also now have this beast dispersing even more EMI with nothing being shielded. So when I tell you guys about an IDS system, and I want you to think, always think what's the most simple applicational platform. Now, servicing a system like this means that in his case, if something was to happen, let's say you're running a system like this with an IDS system and a drive needs to be replaced, you have to rewire that new drive, remount it, do all that. Okay? In a G540 system, all you would do is remove the actual backplate cover. I have a video on this. And then you would just snap out the drive that plugs into the main board, snap in another drive that plugs into the main board, replace the back cover, and you're back up and running. So you figure out the math on which makes more sense. And this is why I tell everybody, before you decide to go about yourself and decide on an IDS system, think about what you're looking at in the future. If you're running a business, in the event that, God forbid, and it always happens at the wrong possible time, and anyone running a business will tell you this, you definitely want to pay attention to these type of applications where if you do get any source of drive failure or electronic failure, you want something to be up and running again immediately. Because most of the time it's going to be around a constraint for a client. And you don't want to have problems with, oh God, how do I do this? You know, now I have to order a drive, I have to rewire the drive. Do I remember how the drive gets rewired? You know, do I remember all that process that goes in that? If you buy a system like this from China, are you going to know definitively how China did this if you don't take pictures and go in here and play with it beforehand? Let me tell you, it's happened to a lot of people. So doing the forethought, which I try to do for many of you if I can, because again, learning from someone else's experience is much less painful than going through it yourself. That is to me a sign of intelligence. And this particular client came to me and said, hey, I don't even want to take a chance with this. I plan on doing business work. He's an actual pilot. And he came to me and said, hey, I'm looking at doing, you know, cabinetry type stuff. And we just talked about it. And when I told him about the G540, it all made sense. And hopefully in this video, now you guys see what I'm talking about when I say IDS system, individual drive system, versus integrated drive system. Okay? There are places where an individual drive system is a must. Okay? Meaning if the table is extremely large, if we're experiencing or I should say if we want to experience variables that are contingent on applications, that's things where we'll have to design in potentially using individual drives for certain applications because you may be using larger motors. Okay, if they exceed the amp capacity of an integrated drive system, which once again, a G540 system's max amp output is 3.5 amps peak, 2.7 amps RMS. Okay, if we exceed that, then we would have to go with an IDS system. Mainly because the motors will not get full stall torque rating unless we use the proper amperage to supply that. So again, there's variables, but do not, under any circumstances, purchase usually on what you think you need, because look, you're paying potentially more than you have to. And I say that to you because I've said this in many videos in the past. You can talk to anyone who's purchased from me. I always try to talk them down from the cliff, so to speak, of spending more if you're not going to see it. If you're going to see it, do it. If not, don't do it. Like if a client asks me, should I go with your 600-ounce motors or 300-ounce motors? Well, it's like a $20 difference to double your torque. What are we doing? Well, I'm doing wood. Well, then it's really up to you on what you decide, but 300-ounce will cut it. You know, it's really a question of what you want to do. And then that same client usually will say, well, you know, in the future, I want to do aluminum. Well, in that case, the $20 investment to go up to the next step makes more sense to double your torque. Again, 37.5 inch-pounds is still going to be a massive amount of torque for you to play with. So we look at that. We weigh the things about your budget. Big thing here, and again, I'm getting a lot more requests for consultations. I try to keep my consultations fair. And what I mean to say is whatever I quote you on the consultation, I try to weed out, because my time is valuable, who's serious and who isn't. Meaning, I simply state a price, and if you agree to it, then to keep things fair, as soon as you purchase a system from me or components to build your system, I credit you that price back so that it's fair. No different than a mechanic typically does. If you go to, you know, whatever mechanic, if they're going to service your vehicle, if you want them to diagnose it and you're not going to have the work done there, they're going to charge you for it. But if you go to work as far as actually having the work done there, they're not going to charge you. To me, that makes sense. It's fair to everybody. Okay? But I have to charge because, again, if I don't, there's a lack of respect in terms of what a consultation really is. And again, there is a lot of work that goes into this. Even though these retrofits seem basic, there's a lot of calculating, you know, okay, well, what about motors? Are they going to work? If the motors from this IDS system are not compatible with the G540, then we have to redo an IDS system that is, like I just stated. Because then again, your motors will not have full operational torque. So again, looking at all this stuff, we have to play a lot of different roles. You know, we're dealing with electronics, we're dealing with engineering, we're dealing with everything. You know, we don't know how old the system is. Is everything good? In this case, this system's actually in really good shape. Other than the controller, he's just doing a straight up retrofit. Nothing big, very, very simple platform. But believe you me, I've had clients come to me in an opposite end of the spectrum where the actual controller may be minimally needing to be redone. And then the opposite end is that the mechanics of the machine are a nightmare. So got to look at all variables, got to look at every cable the system has, what each cable is actually doing. I tell my clients that all the time. You know, the cable here, the digital interface cable, is this required to be shielded? Not really. Okay. Main reason is, number one, it's a very short wire run. Why they did this with this giant cable was, of course, because it's much easier to find a cable that is pre-made rather than putting a cable in that's only, a couple inches to the front of the chassis. It's typically done. They didn't even take the time to wind it up and, do what they should have done. So again, looking at this, we can see corners, of course, always being cut to get the system out, just to produce motion. They consider it done. Stability is second as far as what we're seeing in quality coming from overseas. This is to be expected. And again, once again, this client did expect that, and that's why he's speaking to me. And that's why I say to you guys, take your time, analyze everything. Don't jump off the cliff until you know for sure what you're doing. Because once you get involved with these systems, and of course this system did not come with a user's manual. The client never stated it. He wasn't expecting it to. So again, we look at this and we see the amount of work here that must be done to rectify this. And he already came up with the fact it's just easier to go with a new controller, because after we talked, there's no way I would ever take a potential client system and say, well, let's rebuild the box you have. Now, I have had clients say to me, hey, you know what? I want to use the controller box that's integrated into, the chassis. You can do that if you choose to. Of course, we would take the VFD out. We would have a single power supply, preferably, and preferably a breakout board power supply. And again, all of the cable guides be removed, all of the shielding cables being installed and grounds being installed. All of that stuff would still have to be done. It's totally up to you on what you use, what you don't use. But be relative to what you're doing. Understand the dynamic of what's involved with a retrofit of this caliber. We look at the wiring here, and again, everything here is pretty basic, nothing crazy. You can see how they mounted everything. I mean, it's really interesting, and you got to give whoever's designing the system credit in some ways to see just the ways, like we see a bracket implemented here, the way that they did that. I mean, they really do, some of them try to show that, hey, we're competent in what we're doing, but when we look at the electronics, it just doesn't make sense. And that's why I'm saying to you guys, you can see down here all of the wiring. We see jumper wires getting done. That's a no-no. You don't see terminal splitters being used as you should, so you're not daisy chaining as we see here. Again, lots and lots of things here to think about. So when you do contact me and you show me a picture like this, and I let you guys know, well, you know what? I won't even bother doing a retrofit on this chassis in terms of rebuilding the box, because I get clients that'll ask me that a lot. Can you just, rebuild what needs to be rebuilt? Well, then I'm just rebuilding the whole thing. So why would I do that? I'm not going to make more work on my end, which in turn you guys pay for in labor. It doesn't make sense. The best way to do it is start fresh. First of all, we analyze a system size. What size is it? If we know what size the system is, then we can put together a solution to automate it. And the cheapest solution, along with being the most accurate and stable, is most likely going to be an integrated G540 system. And that's why we see so many of them out, whether it's mine or anyone else's. That's why you see the G540 as prominent as we do, because it's a very simple solution. When we see stuff like this, there's very, very few people that find the amount of labor that goes involved in this attractive, unless you really, really, really want to just learn how to do everything. And I'm not going to be honest, I have certain people that want that. They want to learn, the ins and outs of the wiring and all that, and that's fine. If that's what you want to do, there's nothing wrong with that. But be realistic. This is not going to be a 1-hour process, a 2-hour process. Usually you're looking, if you're a novice and you've never built a system before, you're going by general diagrams, general support, possibly form support, which we see done a lot, which is bottom line, scary in most cases because you don't know who you're learning from. You could be there for weeks, sometimes months, building a system, and I've seen it. And with a client like this who already has a business model, wants to get everything up and running, it's hey, Vin, I want a solution. And I deal with a lot more clients like that. They listen to me, listen to reason. They're like, look, I want to start making money. That's where it's at. So at that point, then the only direction I have is check the system size out, check the motor size out, and right, here we go. I mean, this is a done deal. I can configure this system, again, with as many options as you need. Do you need spindle control? Do you want spindle control? Do you want home switches, which you don't really need because you can use soft limits? Again, we can go as small or as big as you want to go, but bottom line, an integrated drive system is always going to be easier. Even if you look at this enclosure in comparison to this, which is a general sized enclosure you would require. Usually I like to stay in about a 20-inch capacity square to actually do a controller for an IDS system, and that's generally comfortable, you know, to work in, and not with dual power supplies in terms of power supplies powering the drive. So when you factor that in, factor in the money, factor in the labor, and that's why I said IDS systems, big money. That's why you're paying big money, not only for the parts, but also for the labor. Okay, all of the connections, if they're done properly, are going to be soldered, tinned. They're going to have ring connectors. You're going to have everything that needs to be done: shield drains, ground bus, terminal splitters, and then whatever accessories the client wants. I mean, there's a lot of work there, guys. A lot of work there. So think about it, you know. Cabling. We always see this. Here you go. I like how they actually are using, you know, more aviation style connectors we're looking at again. And of course, no shielding. Nothing is shielded here. Just general heat shrink here, just designed to, once again, be mounted with their actual connectors here. Nothing special. All but useless. All these cables have to be replaced, and that's in best practice. So again, once I find out the cable lengths, as a matter of fact, in this email, that's what he was getting back with me on, is just looking at cable lengths. So we could, once again, isolate what lengths he'll require for the system, and we can go from there. But looking at this, again, you can see exactly how appealing it is. You know, a guy just getting in the industry, this is an appealing looking system. It's really robust. It's got the size for most guys that are like, wow, I can do so much on this. And you can, but be smart enough to realize what you're getting involved with, because no matter how many times I do these videos, I'm getting constant messages on, what do you think of this chassis? Is this the one to go with? What do you recommend for this? What do you recommend for, you know, a US-based manufacturer? And then when I discuss US-based manufacturers and they compare the prices, it's kind of obvious. So we have to look at that. And again, we have to analyze your budget, and then you make the decision on which way you want to go. But again, guys, I hope that this video has been helpful. I hope now you guys really have a good understanding of what an IDS system is, because an IDS system, for most of you, is not the way most of you want to go. If you're looking to make money quick, again, with a super stable system, super accurate system, the G540 drive is going to be your best friend. Pending, of course, the chassis fits it. Now, in this particular instance, this chassis is using NEMA 34s, but they're low amperage. So in this particular instance, G540 system works like a charm. So you're not going to have any problems. Chassis is a little longer. Client's not too concerned with speed. He's just ready to make money, like a lot of you. So if that's the case, this makes total sense. And that's why I say keep the investment as low as possible. And that's something else to discuss. You know, later on I get this question, can I upgrade a system later on if I decide to? You certainly can. You can always change a controller, much easier for most part than changing a chassis. But be realistic, and why I say be realistic is there's a point of no return with all chassis, meaning just because you change drives doesn't mean you've just crossed the hill into, you know, where the golden opportunity is. It's not going to make usually that big a difference if you've already got sustained accuracy and repeatability. What we're really looking for is, are you going to be more productive? If the speed increase is not massive, then really what are you paying for? You know, some guys will pay for an extra 5 minutes saved on a job. Some guys won't. I'm not one of them. Okay, 5 minutes isn't going to make a hell of a lot of difference for most guys, especially when you can build in a lead time for your clients, which you should, in my opinion, be doing that anyways. So, again, I hope the video has been helpful. I tried to keep this as short as possible, but again, a lot of information to cover. I hope that it's answered many of your questions. I'm sure it's also created some, as every video does. Please don't be afraid to message me direct at storm2313@gmail.com. You can also message me through my eBay store, eDealers Direct. You'll see links in the beginning of the video and at the end. I thank you all for your support. Take care.